Welcome back for another deep dive. Ready to explore some more cutting-edge tech with us today?
Always. What were we tackling this time?
We're diving into the world of artificial intelligence today.
Nice.
More specifically, all that AI jargon
Yeah.
that can make you feel like you need a whole new dictionary.
It's true.
You ever get that deer in the headlights feeling when someone starts throwing around terms like AI agents or deep learning?
Definitely happens to me all the time. It can be a bit overwhelming.
We've got you covered.
Okay.
We're going through some key terms from Glossaire de l'intelligence artificielle. Termes essentiels. Almost like a cheat sheet
Oh, cool.
for understanding all the AI experts.
Love it.
So let's jump right in.
Yeah.
How about AI agents?
Ooh, good one.
I think a lot of people hear that and they think of like, a sci-fi robot butler.
Right.
But what are AI agents really all about?
Well, you're not totally wrong with the robot butler idea.
Okay.
An AI agent is essentially a system that can perceive its environment, make decisions,
Uh-huh.
and then take actions to achieve a specific goal.
So like a self-driving car.
Exactly. Perfect example.
Oh, okay.
They're constantly collecting data from their surroundings, making judgments about how to navigate safely,
Right.
and adjusting their course based on those judgments.
So it's not just about like, booking appointments and writing emails like a human assistant.
Right.
It's about a much more sophisticated level of decision making.
Exactly. Exactly.
Wow.
And the development of AI agents
Yeah.
is progressing so rapidly.
Really?
There are research teams working on building AI agents that can manage complex tasks, like writing code,
Wow.
designing experiments,
That's wild.
even composing music.
That's incredible. It makes you wonder what kind of jobs AI agents will be doing in the future.
I know, right?
Now, you mentioned that AI agents make decisions.
Yeah.
Is that where chain of thought comes in? I've heard that term a lot lately, but I'm not sure how it connects to AI decision making.
Yeah, chain of thought reasoning is a fascinating development in the way AI solves problems.
Okay.
Earlier AI models often struggled with tasks that required multiple steps of logic.
Oh, I see.
They couldn't break down a problem into smaller, more manageable chunks like humans do.
Uh-huh.
But with chain of thought reasoning,
Yeah.
AI can now mimic this step-by-step approach,
Okay.
which opens up a whole new level of problem-solving abilities.
So it's like AI is learning to think more strategically.
Yes.
Just like we do when we're tackling a complex challenge.
Precisely.
Cool.
And this has big implications for fields like logic puzzles, coding,
Wow.
even scientific discovery.
That's amazing.
There are new AI models called reasoning models that are specifically designed for this type of chain of thought reasoning.
That makes me think of deep learning, which I always picture as like building a brain for AI. Is
Mm.
there a connection between those concepts?
There is. Deep learning is all about using layers of algorithms called neural networks to process information in a way that's inspired by the human brain.
Mm-hmm.
It's a powerful technique that allows AI to learn complex patterns and relationships from massive amounts of data.
So deep learning plays a crucial role in enabling AI to perform those multi-step reasoning tasks we were just talking about with chain of thought.
Exactly.
Oh, so it's like deep learning provides the foundation for more advanced AI capabilities like chain of thought reasoning.
Exactly.
Okay, so deep learning requires a lot of data, right?
Right.
Does that mean the more data you feed it, the better it gets at making decisions?
That's the general idea, yes.
Right.
Deep learning models are like sponges.
Mm-hmm.
They soak up information from the data they're trained on.
Okay.
And the more data you give them,
Yeah,
the better they become at identifying patterns and making accurate predictions.
that makes sense.
Of course, the quality of the data matters too,
Right.
but the sheer volume of information is a key factor in deep learning.
This might be a bit of a tangent,
Sure.
but I'm curious about the practical side of things. Are companies actually using deep learning to build real-world products, or is it still mostly a research concept?
Oh, deep learning is definitely being used in the real world
Okay,
in a big way.
really?
Think about those personalized recommendations you get on streaming services
Uh-huh.
or online shopping sites.
Oh, yeah?
Those are powered by deep learning algorithms that analyze your past behavior and predict what you might like next.
I never realized that. So it's not just some futuristic technology.
Right.
It's already shaping our everyday experiences.
It really is.
That actually segues perfectly into fine-tuning, another AI term I've come across.
Okay.
Is fine-tuning related to deep learning at all?
Absolutely.
Yep.
Think of it this way.
Yeah.
Deep learning gives us these powerful general purpose AI models.
Uh-huh.
capable of learning a wide range of tasks.
Okay.
But what if you want to make an AI model excel in a very specific area, like medical diagnosis or financial forecasting? That's where fine-tuning comes in. It's about taking a pre-trained deep learning model and then training it further on a specialized data set to refine its abilities for a particular task.
So it's like taking a general AI model and giving it specialized training for a specific job.
Exactly.
Interesting. Is that how tools like ChatGPT are built?
Yeah.
Using these so-called large language models? I've heard that term.
Yes.
But I'm not entirely clear on what an LLM actually is.
You're spot on. Large language models, or LLMs, are essentially deep learning models that have been trained on massive amounts of text data.
Oh, wow.
They've learned the nuances of language and can generate text that's remarkably human-like. ChatGPT is a prime example of an LLM in action.
So these LLMs are like giant dictionaries in AI's brain.
More like intricate maps of words and phrases, capturing the relationships and patterns within language.
Interesting.
When you ask an LLM a question, it's not just searching a database for a pre-programmed answer. It's using its understanding of language to predict the most likely and relevant response based on the patterns it's learned from all that text data.
That's mind-blowing. It's like AI is developing its own intuition about language.
It really is.
Okay, so we've talked about deep learning and LLMs. What about those neural networks that are at the heart of it all? Are they the reason we're seeing so much buzz about generative AI lately? You know, those AI-generated images and videos that are popping up everywhere?
You're right.
Yeah.
Neural networks are the foundation of deep learning.
Okay.
And they've played a huge role in the recent advancements in generative AI.
Okay.
What's fascinating is that the concept of neural networks has actually been around for decades.
Oh, really?
But recent breakthroughs in computing power,
Okay.
particularly with those graphics processing units, or GPUs, originally designed for video games,
Oh, wow.
have given neural networks the boost they needed to truly shine.
So video games are partly responsible for the AI revolution.
In a way, yes.
Who knew? Now I have to ask about weights. I've heard that term thrown around.
Yeah.
But I'm not sure how it relates to all this AI learning we've been talking about.
Weights are essential to understanding how AI models learn and make decisions.
Okay.
Imagine each piece of information an AI model learns is assigned a weight, like a tiny scale.
Okay.
The heavier the weight, the more important that information is to the AI when making a prediction or judgment.
So weights are a way for AI to prioritize the information it's learned.
Exactly.
Oh.
For example,
Yeah.
let's say you have an AI model that's designed to predict house prices.
Okay.
The model might learn that the number of bedrooms, the square footage, and the location all influence the price of a house. But the model will assign different weights to each of these factors based on how strongly they correlate with the final price.
Okay.
The weight given to number of bedrooms might be higher than the weight given to color of the front door. Because the number of bedrooms generally has a stronger impact on the price.
That makes perfect sense. So weights help AI determine what truly matters when making a decision.
That's it.
Okay.
And what's even more remarkable is that as an AI model processes more and more data, it's constantly adjusting these weights, refining its understanding of which factors are most important.
Interesting. So it's like AI is developing its own intuition based on the patterns it's observed.
It really is.
That's fascinating. It makes you realize that even though AI can seem complex and mysterious, it's really built upon these intuitive concepts.
Absolutely.
Well, I think we've covered a lot of ground here, from AI agents to weights and everything in between.
For sure.
But before we move on, is there anything else about these foundational AI concepts that you think our listeners should know?
You know, one important thing to keep in mind is that the field of AI is constantly evolving. New terms emerge. Existing concepts evolve. And sometimes even the experts have to rethink their understanding of how AI works.
Oh, wow.
But that's also what makes it such an exciting field. There's always something new to learn and explore.
That's a great point. So even though we've unpacked a lot of jargon today, it's just a snapshot of the current state of AI.
It's exactly.
Who knows what new terms we'll be grappling with a year or two from now.
I know, right?
Okay, I'm ready for the next challenge. Let's dive into some more AI terms.
Let's do it.
All right.
I think our next term, natural language processing, or NLP, is a perfect example of how AI is becoming more and more integrated into our lives.
Oh, NLP. I've definitely heard that one a lot.
Yeah.
But I always get it mixed up with those big language models we talked about earlier. How are they different?
That's a great question. So LLMs are a type of AI model,
Okay.
while NLP is a whole field of study within AI. It's all about enabling computers to understand, interpret, and generate human language.
So LLMs are a tool used in NLP.
Exactly.
Oh.
LLMs are one of the most powerful tools we have for NLP tasks, especially when it comes to things like machine translation or text generation.
Right.
But NLP encompasses a much broader range of techniques and applications.
Okay, that clarifies things.
Good.
So what are some other examples of NLP in action besides those LLMs?
Think about all the ways you interact with language on your devices.
Okay.
When you use voice search on your phone, that's NLP at work.
Oh.
Or when you get spam filtered out of your inbox.
Right.
That's NLP too.
Wow.
Even those chatbots that pop up on websites to answer your questions.
Yeah.
They're powered by NLP.
Wow, I never realized how prevalent NLP already is. It's like we're teaching machines to speak our language, and they're getting pretty good at it.
They really are.
Okay, on to the next term.
Okay.
This one sounds a bit intense. Reinforcement learning. It makes me think of some kind of rigorous AI training program.
That's a pretty apt analogy.
Yeah.
So reinforcement learning is all about training AI agents to learn through trial and error.
Oh.
It's like teaching a dog new tricks.
Right.
You reward good behavior. You discourage bad behavior.
So instead of like explicitly programming the AI with all the rules, we let it figure things out on its own through rewards and penalties.
Exactly.
Oh, well.
The AI agent interacts with its environment, takes actions, and receives feedback in the form of rewards or penalties. Over time, it learns which actions lead to positive outcomes and adjusts its behavior accordingly.
That sounds incredibly powerful.
It is.
But also a bit unpredictable.
It can be, yeah.
How do we know the AI agent won't learn the wrong things?
That's one of the big challenges with reinforcement learning. Is designing the reward system carefully to ensure the AI agent learns the desired behaviors. It's like setting up a system of incentives for a child. If you reward them for getting good grades but not for helping around the house, they might focus solely on their studies and neglect their chores.
That makes sense.
Yeah.
So it's not just about letting the AI loose in the world.
All right.
It's about guiding its learning process with the right kind of feedback.
Precisely. And the more complex the task,
the
more challenging it becomes to design an effective reward system.
So where is reinforcement learning being used in the real world?
So reinforcement learning is already making waves in fields like robotics. Where it's used to train robots to perform complex tasks like grasping objects or navigating unfamiliar terrain.
Wow.
It's also being used in game development
to
create more challenging and adaptive AI opponents.
Cool.
And it's even finding its way into finance.
Really?
Where it's used to optimize trading strategies and manage risk.
It sounds like reinforcement learning has the potential to revolutionize a lot of industries.
It absolutely does.
Now, for a term that sounds a bit more philosophical, singularity. What's all the buzz about the singularity in the world of AI?
The singularity is a hypothetical point in the future. When artificial intelligence surpasses human intelligence.
Oh, wow.
Leading to rapid and unpredictable technological advancements.
So it's like the ultimate AI takeover scenario.
Well, not necessarily a takeover. The singularity is a highly speculative concept. And there's no consensus on what it would actually look like. Or when it might occur, if ever. Some people believe it could lead to a utopian future where AI solves all our problems. While others fear it could have negative consequences for humanity.
It definitely makes you think about the long-term implications of AI.
It does.
Speaking of thinking critically,
Yeah.
how about the Turing Test? That one always intrigued me.
The Turing Test.
Yeah.
It's a classic test of a machine's ability to exhibit intelligent behavior that's indistinguishable from human behavior. It was proposed by the brilliant mathematician Alan Turing back in the 1950s.
So if an AI can fool a human into thinking it's another human, it passes the Turing test.
That's the basic idea. There are different variations of the test, but the core concept is the same. Can a machine communicate and interact in a way that's so convincingly human that we can't tell the difference?
Has any AI actually passed the Turing test?
There have been some claims of AI passing the Turing test over the years,
Really?
but these claims are often debated.
Okay.
The Turing test is more of a thought experiment
Right.
than a definitive measure of intelligence.
Okay.
It raises questions about what it truly means to be intelligent and whether machines can ever truly replicate human thought.
It's a fascinating concept.
It is.
And it makes you wonder if passing the Turing test is even the right goal for AI development.
That's a great point. Perhaps we should be focusing on building AI systems that complement human intelligence, rather than trying to perfectly replicate it.
Okay, let's shift gears a bit
Okay.
and talk about AGI, or artificial general intelligence.
Okay.
How is this different from the AI we've been discussing so far?
So most of the AI we interact with today is what we call narrow or weak AI.
Okay.
It's designed to perform specific tasks, like playing chess
Right.
or recognizing faces.
Okay.
AGI, on the other hand,
Yeah.
is the concept of an AI that possesses general intelligence, capable of learning and performing any intellectual task
Wow.
that a human being can.
So AGI is like the ultimate goal of AI research.
In a way, yes.
Creating a machine that can truly think like a human.
Right.
Yeah.
AGI is still a hypothetical concept,
Right.
and there's no clear roadmap for how to achieve it.
Okay.
But it's a driving force behind a lot of AI research, pushing the boundaries of what's possible.
It sounds like we're still a long way from creating a true AGI.
We are,
Right.
but the progress being made in AI is remarkable. Who knows what breakthroughs might be just around the corner?
Okay, let's demystify machine learning.
Yep.
It's a term that gets thrown around a lot,
It does.
but what does it actually mean?
Machine learning is a subset of AI that focuses on enabling computers to learn from data without being explicitly programmed.
Yeah.
Instead of giving a computer step-by-step instructions,
Right.
we feed it data
Yeah.
and let it learn patterns and make predictions.
So it's like AI is teaching itself,
Yeah.
figuring things out based on the data it's given.
Exactly. That's the power of machine learning.
Okay.
It allows AI systems to adapt and improve over time, becoming more accurate and efficient as they process more data.
It sounds like machine learning is the engine driving a lot of the AI advancements we're seeing today.
It absolutely is.
Okay, this next term sounds a bit ominous. Black box.
Ooh, spooky.
What's so mysterious about the AI black box?
The black box problem in AI refers to the difficulty in understanding how some AI models arrive at their decisions. They can be so complex that even the developers struggle to explain why an AI made a particular choice.
So it's like AI is making decisions, but we don't know how it's making them.
That's the challenge.
Okay.
And it can be a concern, especially in applications like healthcare or finance, where we need to be able to understand and trust the AI's reasoning.
It's like the AI is giving us the answers, but we don't have the solutions to the test.
That's a great analogy.
Okay.
It highlights the need for transparency and explainability in AI systems.
Yeah.
We need to be able to understand how AI is making decisions.
Right.
Especially when those decisions have real-world consequences.
Makes sense. I think we've covered a lot of ground here.
Yeah, for sure.
I feel like I have a much better understanding of all those AI terms that used to make my head spin.
Good.
What do you think? Are we ready to wrap things up? Or do we have a few more terms to tackle?
I think we could squeeze in a couple more. Are you game?
Absolutely. Let's keep this AI jargon train rolling. All right, what other AI gems are we unearthing today?
Let's talk about supervised learning.
Okay.
It's a key concept in machine learning.
Okay.
It's like having a teacher guide the AI's learning process.
Okay, so it's not just throwing data at the AI and hoping for the best.
Right.
There's some structure involved.
Exactly. In supervised learning, we provide the AI with labeled data, meaning we tell it what the correct output should be for each input.
Gotcha.
Think of it like showing a child flashcards with pictures of animals and their names.
So the AI learns to associate the input, the picture, with the correct output, the animal's name.
Precisely.
Oh, okay.
And once the AI model has been trained on enough labeled data, it can then make predictions on new unseen data.
Okay.
This is how things like image recognition and spam filtering work.
So it's all about learning by example. What about unsupervised learning then?
Okay.
Is that like letting the AI figure things out on its own without any guidance?
That's a great way to put it.
Okay.
In unsupervised learning, we don't provide the AI with any labeled data. We simply give it a data set and let it find patterns and relationships on its own.
So it's like giving someone a giant jigsaw puzzle with no picture on the box.
Exactly.
And saying, good luck.
It's a more exploratory approach.
Okay.
Unsupervised learning is often used for tasks like clustering,
Okay.
where the AI groups similar data points together, or anomaly detection, where it identifies data points that are unusual or unexpected.
Interesting. So supervised learning is about learning from labeled examples.
Yes.
While unsupervised learning is about discovering hidden patterns in data.
You got it.
Cool.
And both approaches have their strengths and weaknesses.
Right.
Depending on the specific task at hand.
Okay, I think we have time for one last term. Computer vision. That one sounds pretty self-explanatory.
It does, yeah.
But what's the AI angle?
Computer vision is all about giving computers the ability to see and interpret images and videos.
Okay.
Just like humans do.
So it's like teaching computers to understand what they're looking at?
Exactly. Computer vision relies heavily on machine learning techniques to analyze images, identify objects, recognize faces, and even understand scenes and actions.
That's a lot.
It's used in a wide range of applications.
Yeah.
From self-driving cars that need to see their surroundings to medical imaging systems that can detect diseases.
It's incredible to think about how much progress has been made in computer vision.
I know, right?
I remember when facial recognition software seemed like science fiction.
It really is.
Yeah.
And as AI continues to evolve, we can expect even more impressive advancements in computer vision.
Yeah.
Imagine a world where AI can not only see but also truly understand the visual world around us.
Right.
Just like we do.
That's both exciting and a little mind-boggling. We've covered a lot of ground today, from AI agents and deep learning to unsupervised learning and computer vision.
We have.
It's been a whirlwind tour of AI jargon, but I feel like I've gained a much better understanding of this complex and rapidly evolving field.
Me too. And that's the whole point of this deep dive.
Yeah.
To empower you with the knowledge to navigate the world of AI with confidence.
Absolutely.
You're now equipped to decode those AI conversations and impress your friends with your newfound knowledge.
And remember, this is just the beginning of your AI journey. There's a whole universe of fascinating concepts and developments out there to explore.
That's right.
So stay curious, keep learning, and who knows, maybe you'll be the one coining the next big AI term.
That's a great thought to leave our listeners with.
So there you have it, a crash course in AI jargon, demystified and ready to use.
Awesome.
Thanks for joining us on this deep dive into the world of artificial intelligence.
It's been fun.
We'll catch you on the next episode where we'll be exploring another fascinating topic.
Sounds good.
Until then, keep those brains buzzing and those curiosity gears turning.